Hello students, welcome back to physics class. In the previous class we were discussing about the pressure, right? So did you go through the video and understand what it is? So let's have a quick recap of what is pressure and the SI unit and then move on to the application of pressure in today's class. So pressure P is defined as force per unit area, that is you can write force divided by area and the unit is Newton per meter square or Pascal, right? So force is measured, the SI unit is Newton and area is meter square. So Newton per meter square or Pascal. So you know that the pressure depends on two factors, that is force acting and area of the surface. So you also have seen that pressure increases as the surface area decreases, right? So we'll move on to the application of pressure in today's class. Okay, a sharp knife has a very small surface area on its cutting edge so that high pressure can be exerted to cut the meat. So you know that if the area is decreasing, then the pressure will be increasing. So if the area of the knife is very small, then you can cut the meat very easily, right? So you can also notice that the butter knife is less sharp than a knife used to cut the vegetables, right? Sharper knife will be able to exert greater pressure and it will be easier to cut the vegetables. So next we'll see the next one. Nails and needles and pins have very sharp ends with a very small surface areas. When a force is applied to the head of a nail, and the pressure will drive its sharp end into a piece of wood easily. Okay, so you can also see it is very easier to burst a balloon with the help of a pin than using one's finger. This is because a pin has lesser surface area and so the pressure exerted is more. The studs on a football boot have only a small area of contact with the ground. The pressure under the stud is high enough for them to sink into the ground, which gives extra grip. So let's see the next one. Trucks and buses have broader tires as compared to cars and bicycle, as larger area reduces the pressure exerted on the ground. Okay, next, water tanks are broader at the bottom than at the top to reduce the pressure. The snowshoes distribute the wearer's weight over a large surface area, preventing his or her feet from sinking in the snow. So the snowshoes has the larger surface area to distribute the wearer's weight over a larger surface area, preventing them to sink in the snow. Okay. The next one will see the concept work. So you all do work from morning till evening. You will be doing so many works, right? So like you will be reading or you will be preparing for your test, etc., right? Although you may be doing a lot of thinking from a physical point of view, you may not be doing any work. Why? And the homework which you are doing is not a work at all in physics. So let's see what is this work. So if you are writing your homeworks or if you are pushing a wall, if it is not moving, then we don't say it is a work. So then what is this work? Work is said to be done only when a force acts on an object and displaces it or makes it move. So when do you say a work is being done? So when you apply some force, if the object moves from one place to the another place in the direction of force, we call it as a work. So if you want to tell a work is being done, there should be two conditions. That is, a force should act on an object and the object must be displaced. If any one of the above condition does not exist, then work is not done. For example, no work is done by the girl here. So force is applied but there is no displacement. So the work is not done. The next one, force is applied on a ball and it moves. So the work is done on the ball by the batsman. So if you want to tell a work is being done in science, so there should be two conditions. You should apply some force and the object should move from one place to the another place. Then you say that the work is being done. Okay, so let a constant force F acts on an object. Let the object be displaced through a distance S. The force F and it is moved through a distance S in the direction of force. Let W be the work done. So the work done is equal to the product of the force and displacement. So work done will be equals to product, means you multiply, right? Force into displacement. So the SI unit of work done. So you know the SI unit of force. So what is the SI unit of force? It is Newton into, what is the SI unit of distance or displacement? It is meter. So it is Newton meter, and you can also call it as a joule. Okay. So if force is equals to 1 Newton and displacement is equals to 1 meter, then the work done by the force will be 1 Newton meter, that is 1 joule. Okay. So did you understand what is a work? So when do you say a work is being done? Right? And what is the formula to find the work done? It is the product of force and displacement. Force into displacement. So the SI unit of work done is Newton meter or joule. So your homework is you have to find out 2 examples for work is being done and the situation where work is not being done. Okay, so till now you know what is the work done in science. So if you want to say work is being done, so there should be a force and there should be a displacement of that object, right? So you have to collect the example for work being done and work is not being done. Okay, so we'll meet you in the next class.